Thank you, everyone. The lights are really bright, so I really don't know what I'm seeing. Thank you for being here. I'm sorry to tell you this is going to be a tough session, not because of the complexity, but because it's the one before the drinks. So I'm going to be asking you a couple of questions just to see if you're still with me, okay? So my name is Dani. I'm a generative AI solutions architect, work at AWS. And today, together with Georgi and Olivier, we're going to be presenting responsible AI in Amazon Bedrock Guardrails. So just to give you a quick agenda, we'll be discussing some responsible AI challenges. We will be talking how we can solve them or tackle them with Amazon Bedrock Guardrails and automated reasoning. We're going to be learning on how Workhuman is implementing these responsible AI actions. And finally, we're going to see a demo, right? So it's not only slides, but you can see that it's actually working. So I'm not going to go through every single example because I'm really confident you've been through this slide a couple of times today. But what I do want to point out is that generative AI is everywhere, and it is affecting different branches, right? If we think about our employees, we want to, boost our employees' productivity. We want to create smart and efficient teams, right? Which take advantage of generative AI to build different tools or products. If we're talking about the customers, we want to give them the best experience, right? And that's where generative AI comes in, helping us create different chatbots and virtual assistants, understanding what's going on in our interactions with customers, and how can we, make use of that data to create personalized user experiences. And finally, what we want to also do is take into account our business and optimize it the best way possible. So what we're going to be doing with generative AI is building applications which can help us with document processing, data augmentation, right? Gather more insights, gather more data, and be able to make better decisions for a company based on that data. So as I told you before, I'm going to do some questions, 4 exactly. First question is, who has built something with generative AI lately? Okay, put your hands up. Don't put your hand down. Make sure that you have the right answer. Who has thought about responsible AI and security challenges? If you haven't thought about it, put your hand down. This is being recorded, so don't lie. Okay, there are some people in the room who have taken this into account, right? I think this is the correct room to say that with great power comes great responsibility. And our responsibility is to not only create generative AI applications, but to also build them in a responsible and secure way, right? Examples, we do not want to create an application where that can give out controversial queries or responses, right? We don't want to have an internet story saying that our application gave out free coupons or free policies and so on, right? We do not want HR to bring down our application because it's giving toxic responses to our internal employees, right? If we're working with user information, we don't want to give all the information out that we can. We want to protect some of that stuff, and also we don't want to have biased results. Okay, so how can we tackle this? Many, or I would say most, or all of the models that we have available come with built-in protections, right? And these are built-in checks on what they're allowed and what they're not allowed to say. So, for example, if I ask, how can I build a bomb at home, it should say, sorry, I'm not able to give you that information. If I say, I didn't like someone that killed Kenny and I wanted to punch him, it would say, I'm not going to give you information on how to achieve this, right? These are built-in checks that all of these models have in place. But how can we go further? So that's where we have Amazon Bedrock Guardrails, right? This is a feature from Bedrock which helps us build those secure applications in different ways. So we can have denied topics that we can apply, right? If there's some topic that we don't want the model to be talking about or our customers to be talking about, we can define denied topics. If we have some specific words, imagine competitors that we don't want to be talking about, that's another filter that we can apply. If we want to filter hallucinations, we've got roundness and relevance to make sure that the responses that are being given back by the model are relevant to the question we asked, right? And we can also, for example, identify, correct, and explain factual claims and responses using automated reasoning, right? Finally, also what we can do is we can set up some filters. So, for example, we can filter if our conversation has toxicity, it has hate, insults, violence, right? We've got a series of filters that we can play around with, and this does not only apply to text, but it also applies to images. Okay, so how does Guardrails work behind the scenes? Is we're first going to set up our guardrail. We're going to have these policies that I just mentioned, right? Deny topic, content filters, sensitive information filter, contextual grounding, automated reasoning checks, and word filters. We're going to configure that guardrail, and it's going to be attached to our invocation, right? Via invoke model or converse. So from here on, when a user makes a query or the model returns a response, it is first going to check whether it triggers one of these checks, okay? And if everything is okay and it did not trigger any filter, it will give us back the response. Okay, so you might think, hey, this is great. I'm using it with Bedrock, but what if I want to use, well, what happens if I want to use another model, which is not inside Bedrock? Good news, this is also an independent API, right? So you can apply this to external models and keep the same configuration. Okay, so you can filter the input, the user input, or the foundation model output. So, just before I talk about automated reasoning checks, what is the difference between machine learning and automated reasoning, right? So as you can see here in the picture, in the slide, when we're talking about machine learning, we normally start out with large amounts of data, right, of examples, and we train a model with this information, okay? From there onwards, we have a model that can make predictions, okay? And you have to take into account that this is a probability, right? This may not always be 100% correct. So I'm going to ask you to put your hand up again if you think you're comfortable with letting a model do assumptions on important company workflows based on the data that has been trained. Okay, no one feels, that doesn't count. No one feels comfortable, and you shouldn't, right? Because at the end of the day, we are talking about probabilities. And what we want to do in important, workflows, processes, we want to, keep it as transparent and secure and verifiable as possible. So this is where automated reasoning comes in, where it doesn't start up with a series of examples, but it's going to start up from a specific information, a specific document. Imagine some kind of internal policies that you have. What's going to happen next is that there's going to be a translation into formal logical language, right? So we're back to the basics, we're back to maths. So what we're going to do is we're going to take these policies and we're going to create mathematical representations of these policies, right? This set of rules with their specific variables, right? So then when we ask a question and we get back a response for the model, what we're going to do is that we're going to transform that input and output, again, into a mathematical representation, and we're going to compare it against the set of rules that we defined at the start. Okay? So you may think, hey, this is familiar. I think you're doing this somewhere else, and that is correct. We at Amazon have been using automated reasoning for quite a while now, and you see, for example, in AWS IAM Access Analyzer, where we verify based on a set of rules if you have access to specific actions or specific resources, right? Or imagine Amazon VPC Reachability Analyzer. These scenarios where we've got a set of rules and we need to know if you can access or not, based on mathematics and not just on large language model probability. Okay, and happy to say that we are the only and first provider that are providing these checks as an API, okay? So just as a high-level overview, how does this work inside Amazon Bedrock Guardrails? So we're going to start out with that source document, right, where we've got imagine our policies. We're going to be able to give it an additional context on what those checks are supposed to be doing. And then we're going to pass it into our automated reasoning checks models, okay? And this model, what's going to do, again, it's going to take these policies, it's going to get out a set of rules. It's going to show you the rules that it extracted from those documents and the set of variables that apply to those rules, right? If those rules are not good enough for you or you want to modify them, you can actually do this. And then this policy will be attached to your guardrail, right? So then every time you interact with Bedrock, you'll have the Bedrock guardrails attached with your automated reasoning policy, and it will verify that the response is factually correct based on the original document that we set up. Okay, so now I'll let Olivier to let you explain how they're applying this in Workhuman.
Thank you, Dani. I'll do some very quick context setting before diving straight into some strategy. We at Workhuman, we're an Irish HR tech company, mainly focusing on recognition. We provide platforms for recognition, for gratitude, performance management, e-commerce store for redeeming your awards, etc. Now, at the heart of all this is many, many small moments of recognition, kudos. These recognition moments have small pieces of text attached to them. The messages, why someone should be recognized, why they excel at something. And while these awards carry some value with them, which can lead to the employees getting some free stuff, getting some free flights, book some hotels, what some of our customers don't always realize is that they're basically building up a massive gold mine of information on their entire organization. These moments of recognition have an incredibly high information density. By analyzing these messages, hundreds of millions of them, we can basically tell who is collaborating with who, which departments are working with one another, which individuals are showcasing very high levels of competence in certain skills. We can detect patterns in retention, etc. But since all of these awards are text-based, in terms of AI for us, we have a very large focus on natural language processing and generative AI. So naturally, the entire boom in Gen AI since 2022 has been very beneficial to us. But due to the nature of this data, the award messages from colleagues between one another, they contain PII data, personally identifiable information. They contain sometimes confidential data, projects that might not have been released yet because it's purely internal. So responsible AI here, when doing the analytics on top of these messages, is a top priority for us. So needless to say, our models are subject to rigorous red teaming, bias testing, and other security evaluations. Now, I don't have the time to go full into our entire responsible AI framework, but I decided to take a little bit more of a pragmatic approach, something that's applicable to many companies that are attending today. And that's two specific Gen AI security strategies that we've adopted, which are the block unless and the allow unless strategy. Basically saying, I want to block any incoming request unless I specifically allow it, or I want to allow any incoming request unless I specifically block it. In the case of the block unless strategy, for example, I can define a number of topics, I can define a number of domains, I can define a number of questions. In our case, that could be something like HR, recognition, skills development. You might see some topics that are a bit further away semantically, such as general greetings, hello, just whatever is needed for the AI chatbot to interact naturally. And we don't always have to be very specific on a certain question or on a certain topic. We have some leeway. We don't have to write exactly the way that that question is formulated within our semantic cache or within our controls. We can do semantic similarity checks. We can apply some reasoning on topic plus description. So we can basically allow anything that is roughly related to these topics, but not anything else. Now, the size of these circles basically represents a certain threshold or a certain strictness to a filter. And we can change these strictness levels on a per topic or per domain basis. So in the end, our entire security strategy could look something like this. Like we can be very lenient on some topics, we can be very strict on other topics. If you would look at the green circles, which, for example, represent HR or recognition, everything in the white is something that's automatically blocked. For example, we don't want our customers to rewrite the entire works of George R.R. Martin using our chatbot because we're paying for it. The allow and less strategy is basically the same, but instead of saying what we allow, we're specifically going to say what we don't allow. And it's good to remember that we can implement these strategies on different levels of granularity. It can be enterprise-wide, like a standard policy. It can be on different solutions. It can be on different agents. It can even be on singular LLM requests within an agent. We can differentiate in these strategies. Now, there's two main reasons that I see why we block certain requests. It can be either for functional reasons or for security reasons. Functional reasons, it's mostly important for industry-specific chatbots, I would say. It's to keep the conversation relevant. We, as an HR software company, we want to keep that conversation within the space of HR. These are, the topics or domains here are mainly decided by our product teams, by functional teams. What is allowed, what should be not allowed. It's to avoid well-intended yet unwanted behavior. And for example, writing or rewriting the entire works of George R.R. Martin is what we consider as unwanted behavior. Or, yeah, questions about poor performers, questions about layoffs. That's not what recognition is about. That's not what we want to talk about. On the other hand, security reasons. This is to protect against clear malicious intent, against attempts of jailbreaking, prompt injection attacks, crescendo attacks. You can go on, but these are mainly decided by the technical teams, by engineering, by architecture, because there's a lot more technical complexity involved into blocking these requests. Now, if we apply these to the strategies that I've just talked about, this is just an example. It's not set in stone, but for example, for the block unless strategy, which is more for industry-specific, domain-specific chatbots, we apply something like semantic similarity controls when we choose for a block unless strategy. Now, semantic similarity is basically something that does not use reasoning. It is basically like a semantic cache, and if we see that the embedding similarity is close enough, we can allow it. Now, of course, this is only one of the many layers of our security. We can't disclose all of them for obvious reasons. But the ones that we block for security reasons, we can do those via AWS Guardrails. It's very hard to semantically detect a prompt injection attack because the variety is so large, we need some degree of reasoning in there. And that is where, for example, denied topics in AWS Guardrails are applicable. As soon as you start working with a topic and description we apply a certain degree of reasoning instead of just looking at embedding similarities. In the other strategy, allow-unless, we can use AWS Guardrails, and more specifically, the combination of denied topics, keyword lists, and everything for both functional reasons and security reasons. Yeah, and both of them can be augmented with prompt engineering, basically because it's such a low-cost and often high-value addition to just add some extra instructions to your system message, etc. Now, the thing is, we're not in 2022, we're not in 2023 anymore. Gen AI is evolving. We're past basic RAG use cases. And oftentimes, when you type a single chat message in a chatbot, it's no longer a single request to a large language model in the backend. More and more, we see more advanced capabilities, the flows, the agents, etc., which means there's multiple LLM requests being made in the backend for every chat interaction that you see in your UI. So different agents or flows might require different security strategies, but they also implement guardrails at different locations within their entire flow. It's not just about we check every input, we check every output, we slap some AWS guardrails on there, and we call it a day. We need to be a little bit more smart about this, especially in the multi-agent systems or workflows. So here's a quick example. Let's say we have a router agent. We have a couple of flows that it can go through. This is purely exemplary, but let's say route 1 could be something like a structured data retrieval, where we first have an LLM call, a text-to-SQL call, or a text-to-JSON call. We retrieve some data, and based on the data retrieved, we formulate a final answer. For different routes, we might choose different input checks. We might choose different output checks. The location here is fairly arbitrary. It's just as an example. But the one or the two patterns that I always see is we will always put an input check on any LLM request that could be the first in an entire flow. We always put an output check on the very last final answer that's being formulated before we return it to the end user. Now, if we want to augment this with automated reasoning, first of all, as Dani already mentioned, we need to identify objective, fact-based questions that have very clear right or wrong answers. There can be no ambiguity. In our case, that would be something like, as a manager, what level of awards can I give? Typically policy-related questions, for example, because they're also well documented. Or if you look at, we have an AI assistant, we have an AI chatbot. It's like, it has a free tier and a premium tier. And when you're asking about the capabilities of the AI assistant itself, what large language models often tend to do in RAG approaches is they might miss conditionals. They might miss the fact that this is only possible, in our case, in the premium tier. That conditional might be overlooked if you retrieve a chunk of data from your knowledge base. And that is basically where automated reasoning checks come in very handy. We can basically put in the entire policy like, hey, if you have premium tier, then the AI assistant can do this, 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 and this. If you have free tier, then the AI assistant can do this, 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 and this. So my tip to everyone out there, if you're going to start with automated reasoning, choose very wisely in your proof of concepts. Choose very wisely in which use case you're going to solve with your first proof of concept, and make sure it's something that's well documented, because that document is going to form the basis for your automated reasoning policy. In agentic workflows and the multi-agent or the flows that we've just seen, we also need to implement it somewhere, and there we need to be mindful of which flows might require automated reasoning, which flows don't. It's not just we slap it on every LLM call as well. And most of the time, the pattern here, of course, is that we check at the final answer that's being returned to the user. With that, I'm going to give it over to Georgi for a quick demo.
Thanks. Right. Hi, everybody. I think you're all excited for drinks. Just stay with me for another 10 minutes, OK? Cool. So we'll start with a quick demo of automated reasoning checks. As you can see, we created a new automated reasoning section in the safeguard. So we'll go ahead and create a new policy. We'll give it some sort of a name. In this use case, we'll just call it leave of absence paid. And then what we'll do is we'll upload a simple document. For this use case, we use the simple HR policy that you can find off the internet. And once we uploaded that, we'll go ahead and give a simple description as to what we're going to do with that policy. So we're going to say employees can ask about eligibility for leave of absence, what sort of benefits they can have, and other things related to it. And then we'll also provide a simple Q&A as well. Now, once we click Create Policy, this can take 4 to 5 minutes, so we've shortened the video for this reason. But what it does is it goes through the policy, tries to identify the important concepts, nouns. You'll create a variable schema, and then it'll generate formal logic that is then back translated to natural language. So when you work with the tool, you don't really need to have a strong mathematical base, really. So you can simply modify the rules, add new ones, or remove them. So we'll go ahead and give this just a couple of seconds to finish building. So you can see a list of rules that it's created. Those are not quotes. This is actual formal logic that's been translated back to natural language, and also the variable schema that it's created. You can modify all of those. You can add new ones. You can remove them, because sometimes it may have misunderstood some of the important concepts. To test it, we'll go ahead and use the playground. We'll put a simple Q&A saying, I'm a temporary contractor. Can you use leave of absence? Say yes. So you can see the result is invalid. And it's invalid with the explanation. So as per our rule, it extracted a few variables. And one thing I've noticed, it said employee level is below senior. So in this use case, it assumed that based on the fact that we said that we are a temporary contractor. So we'll go ahead and modify that. We'll say to not make any assumptions, and also to only use this variable if it's explicitly stated in our Q&A. Now, we'll save this change, so all of the policies are versioned, so we'll make sure to save this. And another thing I've noticed, so when we talk to it for our Q&A, we use a temporary contractor, and for the full-time employee variable, it extracted and put it as employee has to work 20 hours or more, which is technically correct. However, we're going to modify that and explicitly say that also if employees work in part-time, then the full-time needs to be set to false as well. Now, once we've saved that, we'll go ahead and try to use the same Q&A again. The only thing we'll change is we'll modify temporary to say part-time explicitly. Now, when we run this, we'll see that validation result is still invalid. However, this time, it didn't assume that we were not senior employee. Now, the next Q&A is somewhat ambiguous. So we're just going to say, I'm an employee. Can I have leave of absence? Now, once we've run this, surprisingly or not, it's actually valid. Now, it is valid because it is a possible conclusion based on our policy if all of these assumptions are valid. So if they are, then it's a possible conclusion that the employee is eligible for leave of absence. So we can use this feedback for our LLM later. Now, to use it in production, it's very simple. So it comes down to creating a guardrail. Within this guardrail, we have a new optional step, which is step number 7. So we can add a new automated reasoning policy. If we click over there, we can enable automated reasoning checks, and we can also choose the policy that we've created alongside the version. So very important to remember to choose the last version. Once we've created this guardrail, we can go ahead and use it in production. So as simple as that. Now let's move on. So let's do a quick recap. To use automated reasoning policy, the first step we need to do is to create the policy itself, which is going to create our structured mathematical knowledge. The next step is to enable this policy that we've created in our guardrail. So if we have existing one, we can enable that in our existing guardrail. We can also make a new one. And then we can go ahead and actually validate our Q&A. Let's look at a simple example that we used again. So leave of absence policy, we say that employees with more than 10 years of tenure, they have to be senior or higher, or they have to be on a VP level or higher. Once we submit this to Bedrock, to automated reasoning tool, it's going to go through all the important concepts. It's going to extract these nouns that will later become variables. So in this use case, it's extracted tenure, level, and allowed. And it also infers the types as well and shows us the descriptions. Once we have these variables, what it does next is it creates some formal logic, so the mathematically based logic that is then translated back to natural language. So when you operate with this tool, you don't need to be strong in mathematics. It's as simple as simply modifying them with natural language. And in this example, we've simplified it a little bit, so we just showcase a simple decision tree, which basically shows our logic. Next is we create the resource itself, so resource for our automated reasoning policies. So here it is important to remember that all policies are versioned, and also each version has a unique ARN. And then we enable it. So we enable it in our guardrails. Now, I want to show you how you should think about using that output from the tool and what you can do with it as well. So let's look at a simple Q&A again. Can I take 1 year of paid leave of absence? And we say, yes, employees are allowed to take up 1 year of paid leave. The first step is we send this over to our apply guardrail API with our automated reasoning policy enabled. Now, what's it going to do is going to see that, hey, you're making a factual claim that this employee is allowed to take leave of absence, which is a possible conclusion based on the policy that we created. However, it's also going to say that you have not mentioned those constraints. So there's a few assumptions that we need to take into consideration. And the first one is employee level has to be senior or higher. They have to have some tenure, so they need to have more than 10 years of tenure, or they need to be a VP level or higher as well. And so once we've actually put it through our apply guardrail API, we would get an output similar to this. And you don't need to go through all of this now. What we'll do is instead we'll go through one of this line by line, starting from the top. We can see that the answer is valid, and it's valid because, again, it is a possible conclusion. Employees are allowed to take up to 1 year of paid leave of absence as per our policy. However, it's also going to give us a list of suggestions. So in this use case, it's going to suggest that it assumes that this employee has more than 10 years of tenure and also the senior or higher. If you remember, it also generates a list of rules, so it's going to give us an explanation based on that we can take into consideration when working with it. Now, what can we do with this explanation? What can we do with this output? Well, there's a few things. The first one is we can ask our LLM to rewrite it. We can annotate the answer, and we can ask clarifying questions. And let's go through all of this one by one. The first one is probably the most simple one as well. We can rewrite the answer. So we have our explanation, we have our output from the automated reasoning tool. We can make a new prompt, we can give it some context and say, hey, based on this explanation, please rewrite the answer. And it's going to do that. It's very simple, but we have to take LLM cost latency into account. So we're ultimately making another round trip before we give the response back to the user. The next thing we can do is we can annotate the answers. So by this time, we would have already created the policy. We know the variable schema, we know the list of rules. So we can programmatically go through it, find out all those unstated assumptions, and we can just make a new string. And in this case, we can append something like, employees must have more than 10 years of tenure, employees must be VP level or higher, right? So slightly more complicated, but then we don't have this extra latency, and we don't pay for those extra tokens either. The next one is probably the most interesting one as well. So we can ask for clarification. We have our variable schema, we have our rules, we can have the LLM ask, hey, what's your position? How many years have you worked at the company? Or we can do something even more interesting. We can have the LLM maybe create a form on the fly that we can send back to the user, and we can have them fill it out in real time as well. So here I think the possibilities are limited by your imagination, and this is the reason why the tool does not automatically rewrite the answer on your behalf, because then you can choose the best approach based on your use case as well. Now we're almost there. So this pretty much sums up how you can use automated reasoning checks to make accurate applications, how you can make applications that are sound, and here I think it's especially important for use cases where you need to give this unequivocal yes or no answer, where you can't have any unstated assumptions. And then you can also make transparent applications. So we give you all the right output that you can use to build a validation decision and then use it further down the line for transparency. In terms of next steps, we have a few resources that I'd encourage you guys to have a look at if you have any interest in the topic. So the first one is automated reasoning, where we show a gentle introduction to the mathematics behind automated reasoning. You can have a read about Amazon Bedrock Guardrails and automated reasoning checks as well. If you have any interest in using the tools, I would recommend reaching out to your account teams. And this is pretty much it. I really appreciate your time. If you guys have any questions, you can find myself, Olivier, and Dani afterwards. Thank you very much.